My guest today is Jonathan Cohler and also Willie Soon. And what do you guys have for us today?
Well, we've prepared a rebuttal of the episode you had the other day with Ned Nikolov, in which he questioned whether global mean surface temperature is physically meaningful or not. And in particular, he focused on a paper by Christopher Essex and a paper by me. And so we're responding to that talk that he gave. So, first of all, you'll notice the picture. That's a person you probably recognize, otherwise known as the devil, and you'll see why that's there in a moment. So we're talking here about global temperature, and we're saying it is physically meaningless. And we're going to go through all the reasons why. So what is global temperature? First of all, Shakespeare framed it this way. Of course, he wasn't talking about global temperature. This was Macbeth. He said, "It is a tale told by an idiot, full of sound and fury, signifying nothing." And in more modern terms, global mean surface temperature is a statistical illusion devoid of thermodynamic meaning and wielded as a prophecy by institutions that have lost their way. Temperature is not global, science is not theater, and truth is not a consensus. So let's talk about what it is. Thermodynamics. Thermodynamics, simply put, is the science of energy flow and conversion. It's how energy moves from one place to another and how it converts from one kind of energy to another. That's all it is, very simple. And there was a particular person who said, more than 100 years ago, thermodynamics is the only physical theory of universal content which I am convinced will never be overthrown. That person was a short man scientist. His name was Albert Einstein. And he wrote this exact wording in 1946 when he was compiling his autobiography, but he was referring to what he thought about when he was developing his special relativity in 1905. And he had already determined that thermodynamics was his model for how to create special relativity. So the other basic thing we wanted to say is I and Willie both love disagreement. We disagree all the time.
Oh, yes.
Disagreement is the core of science. And we love, especially, being proven wrong. So when I heard there was someone doing a video and contradicting what I said, I was very excited to see it. But unfortunately, we were very disappointed because we weren't proven wrong. Okay, so here we go. So the first paper that Ned Nikolov talked about was Essex et al. 2007. This paper is about whether or not a global temperature exists, and it's the seminal paper on the subject, even though this has been understood for more than 100 years. But this is the seminal paper. And he said, there is no physical meaningful global temperature for the Earth in the context of the issue of global warming. So it's important to be careful about what we're talking about here. This entire discussion is about Earth surface temperature, and in particular, what is known as GMST. It's not about the moon. It's not about anything in Ned's papers about other planets and things. We're not discussing any of that because those are completely different subjects. So this is the subject. And then the other paper is a paper that I wrote called Cohler 2025. And in that paper, I said in the abstract, GMST does not have a precise regulatory definition and is in fact physically meaningless. And I also noted just here, you'll notice here, I'm talking about the IPCC assessments, and I'm talking about global warming. We're talking about Earth, the planet Earth, the surface of the Earth. Okay. So now here's what Ned Nikolov claims. He put up a slide at the beginning of his talk, and here he listed for us statements that Essex et al. Made and that my paper Cohler 2025 made. In blue, he listed the ones that he said were true, and then in red, he listed the ones that he said were false. And you'll notice, let's see right there. So the red colored
Yeah.
statements are false.
Indeed, we want to thank him for this very organized nature so that we can actually talk about it point by point about why he's wrong. Yes? Thank you, Nikolov.
And
Thank
that's
you,
why,
Ned.
so we're going to address every one of these points here. Okay. So now we're going to tell you why Nikolov is wrong. We start off with what is global temperature? So the IPCC defines it this way. Now, mind you, remember we said global temperature doesn't even exist. So we don't define it because it doesn't exist. We're just telling you what other people define it as, the primary one being the IPCC. IPCC says it's an estimated global average of near-surface air temperatures over land and sea ice, and sea surface temperature over ice-free ocean regions, with changes normally expressed as departures from a value over a specified reference period. Okay? That is a strange definition, but we'll get back to that. But that's their definition from the Annex 7 glossary of AR6. And then they also define global warming, which is what we're talking about, the context of global warming, refers to the increase in global surface temperature relative to a base. Now, notice, by the way, that's a different term than global mean surface temperature. So I'll get to that in a second. An increase in global surface temperature relative to a baseline reference period averaging over a period sufficient to remove interannual variations, for example, 20 or 30 years. So that's
Well, I think here it's appropriate to interject and then explain things that we think that why Nikolov and a bunch of people still believe that you can take bunch of thermometers that you measure the local temperature at that location, even in your room. You put a thermometer in there, insert into the, well, it's staying in the air. What you do is that what happened to that measurement is that you are actually sensing a local thermodynamics equilibrium within the air and near the mercury.
right. I think
That's what you're doing.
exactly.
And then what we're saying is that you cannot take one of this point here and then insert another point over there, another point somewhere else in the desert, another point somewhere else, and then average them. Therefore, this global temperature concept is totally flawed according to thermodynamics.
we're going to get
Because
to
you
all,
explain the condition later.
we're going to
Yes.
get to all of that. So let's just take it step by step here. So we have, this is their definition of global warming. That was their definition of a global mean surface temperature. And then they have another thing called global surface temperature, which means either global mean surface temperature or global mean surface air temperature, because the GMST includes both land and ocean, and GSAT is only air. Okay. All right. So what is warming now? So we defined what those terms mean according to the IPCC. Warming is a net transfer of energy into a system. It's a measurable increase in internal energy, which is often in physics notated as delta U, and energy is measured in joules, which is the same as watt seconds, which is the same as kilograms meters squared per second squared. And joules is usually the simple one, notated with a J. But energy is not measured in Fahrenheit, Celsius, or Kelvin. And you'll see there, it says degrees Fahrenheit, degrees C, but no degrees K. That's not a mistake. That's because about 8 years ago, the SI units redefined everything, and now K no longer uses the degree symbol officially. So when you write K, you're not supposed to write degrees K anymore.
This is our original arrangement, by the way, F, and then forget about the U, and then you have a C and a K. U is internal energy, by the way. Thank you.
Okay.
I'm proud of inventing that.
Okay. Now, so what is temperature? Temperature is, very simply, and this is not me, I'll show you in a second, but this is what it is. It is a property of equilibrium systems. In other words, it doesn't exist outside of equilibrium. It happens as a property of equilibrium systems. It's what a so-called intensive property, which we'll tell you in a minute. And the definition is either of those two equations, T is du ds, or 1 over T is ds du.
Explain what S is entropy.
U is
internal energy.
U is internal energy, S is entropy. V, and the little Vn at the bottom means while volume and number of particles are held constant. Okay, that's why it's put as a subscript. Okay, so you can define it either way. The first one is the most common definition. The second one is another definition.
Well, we might as well explain it a little bit.
No.
Formula later. Okay, fine.
It's all explained later. Yeah, because we want to go through it logically here. Okay, so here you have the #1 textbook on thermodynamics by a man named Callan. This is the latest edition, published in 1985. And he originally published this in around 1960. This is the third edition. It's 1985. Chapter 2, you can see the conditions of equilibrium. All right. So one of the conditions of equilibrium is temperature. But basically what you have here is internal energy is a function of S entropy, V volume, and number of particles. And you might have different particles, like in the atmosphere, you've got nitrogen, so that's N2. And then you might have oxygen, which is O2.
Carbon dioxide.
And so you could have any number of different kinds of particles, and each one of those N's is the number of each kind of particle in the thing. And this, by the way, all of this applies not just to gases. Thermodynamics applies to everything, okay? So the gas discussion we'll get into in a minute, but so you have a function of SV and all the N's. If you do the first derivative of that, if you remember your differential calculus, then you get du equals du over du ds partial derivative ds, du dv partial derivative dv, and du dn sub j partial dn sub j. And you'll see all the little subscripts. That means while holding all those others constant. But it's a very simple formula. It's just a derivative of all the components. All right. Now, these derivatives, du ds, du dv, and du dnj, appear over and over again in thermodynamics. So they're given names. They're just assigned names. And the one we're going to talk about is this one called temperature. And you see that little equal sign? That's not a misprint with the 3 lines. Doesn't mean that it equals. It means that that's the definition.
Definition. Yep.
Okay. So temperature is defined as du ds. Pressure, you might wonder why it's negative du dv, but if you think about it for a second, if you decrease the volume, then the energy goes up, obviously, right? That's why it's negative. It's actually a sign convention. You could define the convention the other way. So there are some textbooks that define it the other way. Then it's positive du dv instead of negative, but doesn't matter. And du dn sub j is electrochemical potential of each type of particle in the mixture, and we're not going to get into those, but we're focusing on temperature. So you can see this is the definition. It was also defined 20 or 30 years earlier by Landau and Lifshitz, some Russian physicists, and they approached it from a statistical process from the micro level up to the macro. Callan defined it from the macro level. And this is the most commonly used textbook in the world today for thermodynamics. Okay, so now we start off. So we've already disproven that statement where Nikolov said that that's wrong, but that is in fact the definition. So it can't be wrong because it's the definition of temperature. The temperature is thermodynamically defined as the partial derivative of internal energy with respect to entropy. And it's no surprise that Essex is correct because he's one of the most brilliant mathematicians and physicists in the world who deals with this subject all the time. Okay, so now global surface temperature. There is none. Why? As we've already learned, temperature is a property of equilibrium. And the surface of the Earth is not in equilibrium. So that's just a very simple proof. No equilibrium, no temperature, period, because it's defined that way. So the Earth has no actual global surface temperature. And by the way, everyone will agree to that if you press them on that point, because it's hard to disagree with the most fundamental definition in thermodynamics. But now, because it's not an actual temperature, you cannot average or add temperatures from around the globe, because when you take a temperature anywhere, what you're doing is let's say you stick a thermometer in the air, you're measuring the temperature.
Or in the water. Yeah.
Or in the water, You're measuring the temperature right around that thermometer in a tiny, small area. And why can you measure it? You can measure it because the thermometer equilibrates with the water or air right around the bulb, a tiny little volume of it. So they
In the
are...
air, we know it's very fast. In the room temperature, is actually the collisional density is on the order of picosecond, 10 to the minus 12. So it's very fast equilibration. So every time you do it, almost instantaneously equilibrate. So you achieve that local thermodynamics equilibrium. That's what you're measuring, and the temperature means only that temperature at that tiny volume of air that is sampled surrounding the thermometer that you poke in.
Right. So if there are no gradients in the energy, as Willie said, that equilibration of the molecules in that small area happens in picoseconds. The thing that Ned Nikolov talked about in his video, which he was confusing with that, was the equilibration of the measuring device to the small area that you're measuring, okay? That depends on how fast your measuring device works and has nothing to do with the equilibration of the thing. But either way, you're measuring a local equilibrium of that tiny little area, okay? So now if you have this equilibrium over here and that equilibrium over here, and let's pretend these are, 10,000 miles apart on the globe, these have nothing to do with each other, okay? They can't even possibly affect each other because they're not next to each other. And thermodynamics is purely local. It's a whole.
What does Essex call this?
He says there's no thermodynamics at a distance. And he says that because popular today, because we now know about quantum mechanics where you have entanglement, which is
spooky action.
Spooky action at a distance, as Einstein called it, right? But in thermodynamics, that doesn't exist, okay? So this equilibrium here, let's say in the middle of Antarctica at negative 80 degrees Celsius, and this one over here at the equator at positive 80 degrees Celsius, have nothing to do with each other. So this one, you measure this equilibrium. This one, you measure that equilibrium. If you add them together, what you get 100 and you get 0, right? If it's minus 80 and 80, you get 0.
So a question is more important is what does it mean?
What does that mean? What's the physical meaning of that? What's at 0 if you add those together? The answer is nothing, okay? So neither is, and so you don't have an actual global surface temperature because of it's by definition, but you don't have a statistical one either because you can't measure, you can't add together or average temperature. By the way, if you remember that previous slide we had, all the intensives are the derivatives of the extensives. So the derivative of energy, the derivative of volume,
Volume.
and the derivative of relative to particle numbers. Each one of those produces an intensive property, like temperature is the first, then you have pressure, then you have chemical potential, and then there's many others, electrical potential, etc. None of the intensives, it's not just temperature, you can't average or add any of the intensives across a non-equilibrium system. It's meaningless. It's totally
now let's move on and explain the 15C.
Okay. Now, so then you say, well, what is everyone talking about? The Earth is 15 degrees C, because you've heard that, right, Tom?
All the microwave sounding unit can measure that thing. The microwave sounding unit one is very cute. Maybe I save it later. Yeah.
That's a separate subject. Let's just, you've heard 15 degrees C, right, Tom?
I have heard that, yes. Yep.
Okay. So what that comes from is the Stefan Boltzmann law. The problem is the Stefan Boltzmann law doesn't apply here because in order for the law to apply, you have to have a whole list of criteria satisfied before that law works. So here are the various things that are not satisfied. So these are all not true. Stefan Boltzmann doesn't apply to non-equilibrium convecting systems, which the Earth is massively convecting and massively non-equilibrium. It's not a uniform sphere. Stefan Boltzmann requires you have a uniform sphere. You'd have to have the solar energy evenly distributed over the planet. It's not. You'd have to have the Earth in radiative equilibrium. It's not. In fact, that one we say may not be because the consensus will tell you that we're not in radiative equilibrium, right? They say there's an energy imbalance, but we're not saying one way or the other, but it may not be. The Earth is certainly not a black body. No single emissivity exists, no effective radiation, all of these things. The atmosphere cannot be treated as a single layer. So every one of these things is a violation of Stefan Boltzmann law. So the 15 degrees you hear is a calculation. It's not measured. It's not physically defined. It's meaningless. It's just a theory based on a whole bunch of assumptions that are not true, okay? So people do it sometimes because they want to make a very simple statement for like a class that knows nothing. So they draw a picture of the Earth and they say, well, look, the sun goes like this and this goes like that, and look, we can get 15 degrees, except that all the assumptions there don't apply. So it's a meaningless number. All right. So global mean surface temperature is not a temperature, first of all, because when you add together or average together separate local equilibria that are part of different equilibrium systems, you don't get a temperature. So that means it's not degrees F, degrees C.
Not degrees C, not
okay.
Okay.
Now, the mistake that many people make is that as Ned Nikolov did, is he said, well, look, if you add this, if you take a temperature of negative 80 degrees C and positive 80 degrees C, and you add them together, and you get 0 degrees C. No, you get 0. Yes, that's true. Negative 80 plus 80 equals 0. That's true. But it's not degrees C because it's not a temperature of anything in the real world. There's no equilibrium. So this system is at negative 80. That one's at 80. Where's the 0? It isn't. It doesn't exist. There's no physical reality that is associated with. So it's not, and it's also not an energy, right? Joules is a completely different unit than F, C, and K. In physics, we have this thing called an algebraic, what do they call it? An algebraic representation of units. And you're taught to do dimensional analysis when you want to see if it makes sense that the equation is true, right? So for that purpose, that algebraic manipulation, we say, okay, 80 minus 80C plus 80C equals 0C. However, if the resulting thing that you're getting is not physical, it isn't C anymore. We only do that for the purpose of dimensional analysis. That is not, it's called a dimensional algebra. It has nothing to do with reality. It's just a calculation methodology, okay? So whether or not the thing you get at the end is the units that you calculated depends on whether or not such a thing exists in the real world, and it doesn't, okay? So it's not energy, it's not any thermodynamic quantity, it's not any kind of climate variable, which is another word that the IPCC created. Okay, so now what we've shown is here, intensive properties are not additive. By the way, it's interesting, Nikolov agrees that intensive properties are not additive. You see he has it in blue there.
The blue, yeah.
Yeah, so he agreed with that. But then he says this is wrong. Because they cannot be added, they cannot be meaningfully averaged. And he says that's wrong. But of course, that's wrong. You can't average something that doesn't exist, right? You have this equilibrium over here, that equilibrium over there. And to create a normal arithmetic average, of course, you have to add them, right? Because that's what an arithmetic average is. So you can't do that already. And they're parts of separate equilibria. The whole system is not one equilibrium. It's many, many, many separate local equilibria.
That's why it's strictly local concept.
That's what Willie was getting at. It's a totally local concept. Temperature is a local concept. And now, up here, he agreed temperature is an intensive property, but then he disagrees it's defined only in equilibrium. Not only is it defined only in equilibrium, it's a property of equilibrium. It doesn't exist otherwise, okay?
This is why if you want to be serious about thermodynamics, let's be serious about thermodynamics. It is one of the holy signs, the science that is so powerful that is correct at all times.
Right.
You cannot just all of a sudden change the rules of what you like or don't like, and then in your own ad hoc thinking, murky thinking, to say that, no, these people don't even know how to explain, oh, it was Clausius who defined this. We understood all of that, please, Ned. We understood every single aspect of those things. The two different formula that we saw of temperature that defined in partial S over partial U, internal energy, or 1 over T, those are all depends on formulation. I mean, you didn't mention the name of Landau-Lifshitz books. It's actually starting from theoretical physics. We're trying to define things starting from statistical mechanics. Cullen is in the school of classical thermodynamics, who really treat the problem very differently, but they reach the same conclusion.
Right.
So please don't play the game about us not understanding anything about how you can relate this sort of stuff to this, but it's strictly applied to equilibrium concept, equilibrium condition. That's basically what it is. Anyway, sorry for interrupting.
Yeah. So here we've disproven this. It's defined only it's not only defined only, it's a property of equilibrium systems. There is no definition of temperature outside of equilibrium systems. None. And this is an important point, because all of the formulas and stuff that Ned spent a long time going through in his talk,
Which we're going to save it for
which
later.
I'll show you in a second, left out the important fundamental definitions of everything that he talked about. Okay, so I'm going to show that to you. And by the way, here it says it can't be meaningfully averaged across, in contrast to extensive properties such as energy, mass, and volume. Energy, mass, and volume can be added and averaged. If you have this much energy here, this much energy here, you can add them together, and that's your total energy. Same with volume, same with mass, same with particle number. If I have 5 particles here and 10 particles here, I have 15 particles. Okay.
Well, in the sense that all the red font that he used should be all blue. That's the problem with
That's
this.
right. Everything we're going to show that
You just see too many colors.
every single thing in red by the end here.
Be all blue.
All blue.
Anyway, go next.
All right. So now we go back to Essex et al. For a moment, who actually explains this quite succinctly. Same thing as Callan, same thing as Landau-Lifshitz, the standard understanding of thermodynamics, the only understanding of thermodynamics, as Einstein said. Thermodynamic variables come in 2 kinds, just 2, extensive and intensive. Extensive variables are proportional to the size of the system. That's like entropy, energy, mass, volume, particle number, etc. If the system gets bigger, you have more particles, more mass, more volume, whatever. Okay, those are extensive properties. The other kind of property is intensive. Those are the first derivatives of the extensive properties. And there are many different kinds, but the most common kind are temperature, pressure, and chemical potential. And those are independent of the system size, and those represent a quality of the system, such as temperature, pressure, chemical. You can't add pressures together from independent systems. You can't add temperatures together from independent systems. So in this case, combining 2 systems does not yield an overall intensive quantity equal to the sum of its components. Very basic. And again, you'll see right here, the temperature of each system is, and Essex just says, of course, because that's the definition. It's from the basic text. It's from the fundamental theory of the subject entirely. It's the most basic first principle. Temperature is du ds. Okay, that's the definition. Period. There is no other definition, by the way. All the other things that people call definitions, like it's a representation of the kinetic energy of the particles. Those are simplifications that are thrown around for junior high school students when you're teaching them some new physics. They're not accurate. They're not even a definition. I mean, representative, what does that mean? The definition has to say exactly what it is, although it's not a definition. But and you'll see why in a second, why those approximations are meaningless. Okay.
Thanks.
So now we've showed nobody has presented any mathematical or physical evidence as to how an average of intensives can represent an extensive. It's not possible.
Completely true statement, yeah.
Okay. So now, thermodynamics says temperature doesn't equal energy, but Ned Nikolov says that temperature relates to energy. And he, in his presentation, derived this set of equations. And he said, thermodynamic temperature is uniquely related to the average thermal energy contained in a unit amount of gas, as described by the following expressions. Now, first of all, that statement is wrong on its face, but let's step back for a moment. We're not talking just about gas. For example, in GMST, as defined by the IPCC, it's an average of air temperature, that's a gas, and seawater, that's not a gas. So these don't apply at all to what we're talking about right off the bat. They also don't apply because it's a core category error. Okay, Nikolov forgot these equations that he showed apply only to ideal gases, which the atmosphere is not, and I'll address that in a second, and only in equilibrium, which the atmosphere is not. Okay, neither the ocean nor the atmosphere are ideal gases, not even close. The Earth's surface is a driven non-equilibrium system. Now,
by the way, the Formula 7 were 2 kgs for diatomic molecules. Yeah.
That's what I was about to say.
Yeah.
Exactly. And so that
strictly
formula
is a common else.
That formula is a common approximation used by weather forecasters and meteorologists, okay, for a completely dry atmosphere. So in other words, the atmosphere has oxygen and nitrogen in it, right? And between the two gases, N2 and O2, that's 99% of the atmosphere, all right? So if all you have is oxygen and nitrogen, and it's completely dry, so there's no water vapor, then those equations are a pretty good approximation of energy within one equilibrium. So in other words, if you have a hunk of atmosphere right here, it's completely dry with 0% humidity, and it's stabilized temperature, then that will give you a good approximation of the energy that you have there. Okay, of course, that has nothing to do with a global non-equilibrium average, number one. And we know the Earth's atmosphere is wildly different. The poles have 0% humidity. The equator has like 100% humidity relative, right? So there's lots of water molecules, H2O, which is a triatomic.
Triatomic, yeah.
Because you got two H's and an O, right? Yeah. They're flying around, and so you have widely varying humidity and all kinds of other things. And they're not ideal gases, and they're not in equilibrium. So what he's given you here is a straw man. Those equations would hold for completely dry air in a parcel that I have right here with 0 humidity and at equilibrium. Then yes, those are not, and even then, by the way, they're not perfect. Those are approximations still, because you still have another 1% of the atmosphere, which is carbon dioxide and argon and other things, right? So this statement is false on its face already. And he's left out the most important parts. He left out that we're dealing with water and non-ideal gases not at equilibrium.
Then
so
you can
therefore,
change 3 phases. Right. Liquid, water, gas, and solid, yeah.
That's right. Water can be an ice, it can be a liquid, it can be a solid, etc. So therefore, Nikolov's temperature-energy relationship does not exist. It's not, we're not saying it's slightly wrong. It doesn't exist for Earth as we know it. He's talking about a theoretical small little case in which those things are a good approximation for a local thing. That's nothing to do with what we're talking about, okay? So it does not exist. There's no temperature-energy relationships like as he proposed there for Earth as we know it. Okay, so now we've got, that's gone. Sums or averages of individual temperatures in the field are not temperatures. Neither are they proxies for energy. Temperature does not have a constant proportional relationship with energy, and there is no global temperature, once again. Okay.
Once again.
So now,
correct statement turned into red. He liked red color too much.
Yeah, we should have turned them all blue as we...
I know, if we know many stuff.
Okay, so now, this next one is a little tricky to understand. So GMST averaging method is arbitrary. Why do I say arbitrary? Arbitrary means that it's not dictated by physics. And I'll show you that in a second. IPCC and NASA chose this method. They chose to use area-weighted arithmetic mean. That was a choice. It was their human choice. There was nothing in physics that said it needed to happen. Okay. So there was no physical principle for that. And we know that temperature is an intensive property and it's neither additive nor conserved nor averageable. So what does that mean? Here's what Ned said. He said, IPC and NASA employ area-weighted arithmetic averaging. Okay. Blah, 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 blah. And then he said, this is still him. However,
Very strange, yeah. Exactly.
this is not without a physical basis. So he claims there is a physical basis. He says, this is not without, meaning there is, right? There is a physical basis. But in the next sentence, he says, it has a mathematical and geometrical basis. Wait a minute. He just moved the goalpost. A mathematical and geometrical is not the same as a physical. Okay. In fact, they're completely disjointed things. By disjointed, I mean they're completely separate things. He says, it's not arbitrary. Okay. Now why?
Well, we're very sensitive to language. Just telling me, don't randomly talk.
Yeah. And physics is sensitive to language. Okay.
Correct.
So there was this guy, scientist.
Another category error, put it this way.
Yes, another category error here. Hume, who back in the 1700s said, look, and he proved this, all the objects of human reason or inquiry fall naturally into two kinds, and the words he used were relations of ideas and matters of fact. So by relations of ideas, if you go read his book, what he means is things like 1 + 1 = 2, mathematics, geometry,
Axiom.
things that you can create in your mind. You make some abstract axioms, and you can prove that 1 + 1 = 2, and that doesn't depend on the planet Earth or the fact that Willie Soon exists or that Tom Nelson exists.
Or Ned Nikolov.
Or that Ned Nikolov exists. It's simply relations of ideas. It's abstractions that you can prove given a set of axioms. You have to start with some axioms, right, that you take. And whereas matters of fact, like Willie Soon exists, we can see that. We can hear him talk.
The sun is there.
The sun is there. We can read the hundreds of papers he's written. And
Only
Tom
8
Nelson,
minutes ago, yeah.
right, and Tom Nelson exists. That's a matter of fact. And the sun exists because we can see it. So those are two separate kinds of ideas. And you cannot prove using math alone anything about the physical world. Anything. Now, what does that mean? Think about that for a second. I can't start from 1 + 1 = 2 and then prove that the sun exists. But what I can do, I can use math to help me understand things in the physical world. So once I realize that the sun exists, I can go measure it and study it and use math to help me understand it. But you can never get from math to physical. You can only get from physical to math. Okay? All right.
Yeah, don't give us geometry stuff. Yeah.
Yeah.
Geometry.
So geometry doesn't do anything. Now, the reason he brings up area weighting and geometry is because if you had an extensive property that extended over the surface of the Earth, like energy, okay, then he's correct. You would want to use an area-weighted arithmetic mean because it's extensive, meaning it extends. The energy is everywhere in space. Okay, and you would have to add it together because it's additive. Extensive properties are additive. So the choice of the area-weighted mean does make sense and is physically dictated if you're adding together, for example, energy or something.
Yeah, absorb solar radiation, so on.
Right, absorb radiation. I'll show you some examples in a sec. Exactly. But otherwise, there's no reason to use that average. Okay, area weighting assumes additivity. Air weighting is physically valid for extensive quantities like energy flux, absorbed solar, outgoing radiation. Temperature, however, is not extensive, so there's no physical reason to choose it. He gave a geometric reason, but that geometric reason doesn't apply because it's not an extensive property. So it's, again, he's going in circles and not getting to the fundamentals. So physics provides no unique rule for averaging temperature. Many inequivalent averages are possible. So if you're going to average it, you can choose whatever averaging you want. There's no reason to choose one over the other. Area weighting arithmetic mean is an arbitrary conventional. By conventional means like not we went to a convention, but it means somebody decided to do that for no particular reason other than that they wanted to do it, and then other people followed that same decision for no particular reason. Okay, so arithmetic area weighted is a conventional choice that IPCC uses, that NASA uses, and that several of the other groups use. I think HADCRUT uses that, right? They all use that same conventional choice for which there is no physical reason whatsoever, period, full stop, okay? So
Next.
here's a problem. Here's an example of when physics does provide a reason to do something. If you remember, did you take physics in high school, Tom?
I did. College too. Yep.
Okay, so then you probably remember this problem. You travel two distances at two different speeds, v1 and you travel equal distances, same distance, call it d, at two different speeds, v1 and then v2. What's the average speed for the whole trip? Do you remember the answer?
I do not. Nope.
Okay. Well, if you do out the arithmetic and do your, distance equals speed
You get the
times
wrong
time,
answer,
right?
wrong answer.
And you do the equations, you'll find the answer is that the average velocity for the whole trip is 2 over 1 over v1 plus 1 over v2, which is known as the harmonic mean. It's not the arithmetic mean. And you just do the arithmetic and you'll see. All you have to know is that distance equals velocity times time. Once you know that and you do the arithmetic, you'll get this answer, okay?
Yeah.
So for this physical property, dictated by the fact that we know that distance is velocity times time, the correct answer is the harmonic mean, only the harmonic mean. If you had calculated v1 plus v2 over 2, the arithmetic mean, you would get the wrong answer, okay? So, key lesson, when physics dictates what is conserved, it dictates the averaging method. Temperature has no such constraint because it's intensive. There's nothing conserved. It's not an extensive property. It doesn't sum. It's a local property only, okay? So that, and now I'll give you a couple other examples of why this is wrong. Well, okay, so the category error is area-weighted arithmetic average is physically dictated for energy and radiation, but not for temperature. Applying it conflates extensive and intensive, okay? Now, there are many different kinds of averaging, infinite numbers. Here are some common examples of physics-based averaging examples. If you're calculating minimum entropy, use it. Physics dictates harmonic mean. Radiation fields, harmonic mean. Parallel resistances, harmonic mean. Traffic flow, the one we just did, harmonic mean. Energy exchange, arithmetic mean.
Yeah, you can use that.
Kinetic energy is root mean square. Statistical mechanics, root mean square. And spring potential energy, like when you squish a spring and it pops out. That's root mean square. Black body radiation, which is the Stefan Boltzmann law, that's fourth root mean. Okay, so those are all dictated by physical principles, not by mathematics. Okay. And here's just some numerical examples so you understand the magnitude. If I take the arithmetic mean of 10 degrees C and 20 degrees C, you get 15. If I take the harmonic mean, you get about 13.33. And by the way, notice I didn't put a degrees C next to these other numbers because those are not temperatures. Okay. Once you average them, they're no longer temperatures, but they are numbers. You can average them, right? Harmonic mean is 13.33. RMS mean is 15.81. T4 mean is 16.6. That is a 25% variation across these different averages alone.
This is why I think Tom asked a question at the end where Nikolov really give a sleight of hand on how NASA gives in the 1980 defined the global temperature as some numbers and then later they change it to another number. What does that mean? Oh, he says related to the number of a station they include. A whole bunch of baloney, this guy. He doesn't know what the database is also. Anyway, so the problems.
So notice I did not include degrees C because an average of two temperatures is not a temperature. Literally, it's not a temperature. It doesn't relate to any equilibrium system. Okay. And here's how Essex puts it, and he puts it ultimately, he's one of the most brilliant mathematicians in the world. And
We'll see at the end. Yeah.
when he says something, you can be sure it's true. He said, if the physics does not prescribe one averaging rule to be used over another, as it does not for temperature, we may use any rule. If one interpreter of the data chooses one rule, while another chooses a different rule, there's no way to settle a disagreement as to whether the system is getting warmer or cooler with time. Because as you saw from my previous slide, different averages give you different numbers, right? And they also give you different trend lines. In fact, he demonstrates as a simple example in his paper, he takes some of the world temperature data, the thermometer data from a bunch of different stations, and he says, look, when I apply this rule, it goes up. And when I apply that rule, it goes down. So which is it
why we say, please read Essex et al. Please take your time. If you really want to learn something, if you want to keep going the way the Ned Nikolov direction, so go ahead. You're not going to learn much.
If the choice of your averaging method can change the conclusion from it's warming to it's cooling to it's staying the same, then that is what is known in mathematics as ill-posed. In English, that means it's meaningless.
Yeah, everything goes.
Okay. Because you're taking a mathematical decision changes the result. You see, now, if you measure temperature, there's many different ways to measure temperature. You can measure it with a standard, mercury thermometer. They have these little things you click on your forehead that measures infrared radiation.
Infrared radiation.
And there's many different ways, but because temperature actually exists, all of those give you the same answer within, small uncertainties of the device, right? But whatever method you use to measure temperature, you get the same answer. Here, because no averaging method is prescribed, you can get wildly different answers, up, down, or the same, okay? So you can't settle a disagreement as to whether the system is getting warmer or cooler because it depends on an arbitrary conventional choice. Okay, so with that, we've now disproven those three. Physics and experiments, he says, do not provide grounds for choosing. He says that's wrong.
No, he challenges, yeah.
He challenges it, but they do not, it's correct. They do not provide grounds for choosing one rule over the other. He confuses, again, the mathematical thing with the physical thing. And there is no basis for concluding that the atmosphere as a whole is either warming or cooling. The only way you can determine, as I said at the beginning, whether the whole climate system of the planet is warming or cooling is by measuring the total net flux of energy in or out of the system.
Which is a whole different class
problem.
of problem all by itself. In fact, for a little advertisement, I'll be talking about that in ICC 16 in the Heartland Institute meeting. Yeah.
And Willie gave a great talk.
I already gave one at the DDP conference. Yeah.
Yeah, really great conference.
And of course, please, our great man, Jonathan, another JC by the name of John Clauser is also talking, a Nobel Prize Physics and laureate, talking about those sort of issues that is much, much more difficult to tackle.
And by the way,
misrepresented, of course.
And by the way, we also have a new paper coming together, Willie and I, on the whole subject of OHC and EEI.
Ocean heat content, yeah. Energy, Earth energy imbalance, yeah. EEI.
So the IPCC and NASA apply area-weighted arithmetic averaging, a statistical convention with no physical basis, is correct. We just showed you why. Okay. Now, I'm coming back to this definition again because we want to show the following two things that he had wrong there. This definition, notice that it says it's an estimated global average, of near surface temperatures, right? If it's an estimate, what's the first question that comes to any normal person's mind?
Estimate of what?
What is it an estimate of? Now, so if your answer is the global temperature, that can't be, because we already showed you there is no global temperature. That's just a thermodynamic fact. It's not even arguable. It's not debatable. It's nothing. Okay.
Mainly to introduce the next two slides. Why are we so passionate to try to insist that global temperature doesn't exist and meaningless. Here's the reason. Go.
Okay, but let me just say one more thing. So what is it an estimate of? There is no global temperature, so it's not that. So then you could say, well, maybe what they mean is, of course, they word this so ambiguously that in like 6 different ways, but maybe they mean it's an estimate of what it would be if we could measure a bazillion points all over the globe. Except that's not true either. Because again, Essex dealt with that issue, but a continuous integral does not have the same properties as a subsampled group. And
It's only limited by the sampling theorem problem.
right, if you know the Nyquist-Shannon sampling theorem, we're only covering an infinitesimal portion of the surface. In fact, most of the 90% of the surface, there's nothing. 99% of the surface,
Make a dot bigger.
nothing.
Your dot bigger on the map so look like fill up the whole page. Excuse me, not physical sampling. It's just very confusing when you look at those maps with a lot of dots. Notice, right? You're seeing it's always filling up.
Right.
There's so many data stations. What are you talking about?
And there is no global temperature. So even if it did converge, and it wouldn't necessarily converge, it's not converging to a global temperature because there is no global temperature. Okay. And in fact, we know it's not convergent because every group that does their own calculations comes up with different answers by significant amounts. Anyhow, so there is nothing. Okay. So now GMST is physically meaningless. Why? The principle of classical realism, which was sort of articulated by Galileo Galilei, John Locke, Pierre-Simon Laplace, Simon Laplace, is that things in the physical real world have properties, like mass, velocity, viscosity, pick a property, whatever you want. Things in the real world have properties, and those properties exist whether or not we go and measure them. Now, the only place where this changes is in quantum mechanics, but we're not talking about quantum mechanics here because the thermodynamics we're talking about is purely classical thermodynamics. In quantum mechanics, you have that whole business of virtual particles and non-locality.
There are even stuff called non-equilibrium thermodynamics. I mean, Chris Essex et al. Published in the Journal on Non-Equilibrium Thermodynamics. So it's really a lot of science involved anyway.
But these guys, Galileo, Locke, and Laplace, were just talking about classical physics, Newtonian classical physics. And so the principle is that things have properties, and those properties exist whether or not you measure them. And those properties have values. Therefore, it's a very simple jump from there. That means no arbitrary statistical calculation can ever represent any real-world physical property. If the choice of how you do the calculation is arbitrary, because there's no physical principle dictating it, and if the results are all different depending on how you did it, then they don't represent something physical because the physical thing has to have a real value. Okay, so GMST is an arbitrary statistical calculation. So GMST is physically meaningless. Okay, now remember, we're talking about Earth, not the moon, not Mars. We're talking about non-equilibrium system because that's what the Earth is. And I don't know, and by the way, I've never said anything about any of Ned's papers or all of his other conclusions about Mars and the moon, because those are complex other systems that have many different characteristics. There's no ocean on the moon, right? And there's a lot of other differences. So I'm not saying anything about his formulas or what he did on other planets. I'm simply talking about GMST in the context of global warming here on Earth is physically meaningless for fundamental thermodynamic reasons that we've explained. Okay, so what does that mean? It nullifies the heart of climate science. That means every chart showing GMST rising and falling is invalid. Every model tuned to GMST is invalid. Every policy based on GMST is invalid. There's no global temperature. There's no average global temperature statistic that has any physical meaning, none. And the Paris agreements, the targets and the treaties, you got your 1.5. I put degrees C in red just to remind you that that's a fake. It's not 1.5 degrees C. It's a 1.5 change in GMST. which is not degrees C. Had nothing to do with degrees C, indeed. Okay. In fact, I said to Willie at one point, we should probably call it degrees G. And then so they know that it has nothing to do with temperature. And 2 degrees faked C are defined using GMST, but GMST is not a temperature, so the Paris limits are numerical fantasies purely. Hundreds of trillions.
Someone tell it to all the politicians.
Yes.
Even some of the scientists. Yeah.
Hundreds of
scientists.
trillions are forecast to flow based on these projected GMST paths, which are based on a unitless fiction misleadingly labeled degrees C. Putting degrees C next to GMST is not shorthand. It's pure deception. And saying that it's an algebraic relationship because I had a C and I had a C and I add them together. Yeah, but you can't add temperatures together. So it's like saying I have a phone number and I added them together. The thing you get is no longer a phone number.
Yeah, all the telephone numbers of the world, yeah. Every them, and then you ring it up. Who pick it up at the end? God or something?
So
I don't know. Ned Nikolov.
Let's say we put the letter P at the end of all numbers that are phone numbers. So we take this phone number P plus that number P equals
Outrageous,
some number. And Ned Nikolov would say P at the end of that because they had P's on them and therefore that has a P on it. No, because the thing that resulted is not a phone number. That's not the way phone numbers work, just like that's not the way physics works. Math does not dictate physics. Physics dictates math. Math exists abstractly, okay? And the neat thing about math is that when you prove something true in math, it's eternal and absolute. It existed before you found it. It will always exist, and it can't be challenged. In fact, I was pointing out to Willie the other day, the proof of 1 + 1 = 2 is far more complex than the proof that GMST is physically meaningless. GMST physically meaningless takes a few bullet points. 1 + 1 =
Whitehead and Russell, right? The 3
Whitehead
volume
and
of
Russell, right.
1,500 pages or something.
They took like 300 pages and 2 volumes before they could arrive at the final result that 1 + 1 = 2. It's extremely complex proof from basic set theory. GMST is simple from fundamental thermodynamics.
Okay, that's gonna keep with that headache. Let's keep going.
That's our last one there. So you see the IPCC acknowledges GMST as a statistic. They didn't say it was a unitless fiction. I did. But they do say that it's a statistic. You saw the definition. It's the average of blah, blah, blah. And it is systematically mislabeled with temperature, just like labeling a sum of 2 phone numbers with a P afterwards. It would be exactly as false as that.
I think, Jonathan, before you go to this ad hominem stuff, which is the end of it,
Yeah.
I just want to make one mention of the stuff where you stopped me was, people say, oh, microwave sounding unit. I measure the global temperature. Don't that mean something? Please remember what they did there. It is a sensor called microwave sounding unit looking down. By the way they're measuring is in microwave, so it's between 5 to 6 millimeter. Okay, you can look at the ruler. You will probably know the wavelength of this thing. So, you see, we work so hard because our brain is so conditioned by the need to convert something physical. You measure the radiant flux, okay, which is a good measure. Why don't we just keep it as that? But we have to somehow find a way to convert that, probably assuming some kind of local black body to convert that into temperature. That's what it is. So this global temperature that even Roy and Spencer and Christie was doing is actually not really a true metric at all, even if you're serious about this. Why don't we leave it as a unit? I remember when I was struggling with this problem, it was really that Jonathan remind me. In 2002, 2003, when I had to deal with this Michael Mann hockey stick temperature history, right? I was thinking, man, just like I was already highly influenced by Essex. By the way, I know him for a very long time, right? So that was 2003. He finally put his paper out in 2007, but that paper is under preparation at least for several years, I would say. Because on and off, he will hint to us. In fact, in 2002, he already hinted that. He produced his book, right, taken by storm. I think Jonathan bought a copy and read it again. It's already involved, Professor Thermos and all that stuff. I had to deal with the problem. Look, you have all this proxy data on each of the local regions, censored by the wood, by the sediment, by corals, by this and that. So what are we going to do about this? Actually, I came out with the thing that, no, I'm not going to take them and average them all together because it's ridiculous. Okay? First of all, it violates this thermodynamics principle, which I already know a little bit back then, probably not as clear as Essex, but we know something. Something is wrong here. And then I actually more realized about, no, there's no way we're going to average this. It means nothing. My comment win because it produced numerical number for people so you can replot and you felt confident. I know this number. I know this number. I'm so smart. I even have error bar. But they're all fake. They have no meaning. That's the reason why I kept my paper when I wrote it. People attack me. Why don't you produce a one temperature series for us? I said, no. It's all of those series. In fact, I say, don't convert them to calibrate because every time when they have a local proxy, they calibrate with a local temperature proxy and then they produce everything in temperature unit. I said, no. Put that, if it's 3-ring width, you produce in the micromillimeter, you can measure. If it's in sediment, you measure the content of the oxygen 18, this and that. Keep it as a natural unit. Don't touch it. That's it.
What Willie's talking,
proposing that. That was a.
what Willie's talking about is when Michael Mann came out with his hockey stick, he got a bunch of proxies and then he did these averages, these global averages. Yeah. So same problem there. His thing was not only had millions of statistical problems, bad data, incorrect calculations, all that, but it was also this averaging of non-equilibrium systems. So that made it completely meaningless. Willie at the time, it was 2003, I think, published with Sally Belluni.
I'm just trying to illustrate we have clear thinking.
But so what Willie's paper did is he sampled, I don't know how many, 1,000?
400 about that, yeah.
Okay, 400 sites from all over the globe.
And then nothing, yeah.
But then he listed all of the local properties of each of those sites. That's meaningful. And you can say, look, we have evidence that it was warmer here, and it was warmer here, and it was warmer here, and it was warmer. Then you could say it's warmer or it's not warmer. And it's not global, it's local, but a large collection of local data is very informative. That tells you what's happening in all the various locations, right? But averaging it together produces a meaningless statistical artifact.
Okay, let's finish up with the fifth
that relies on thermodynamics.
Say this because I've been really keeping this for a long time because, you know, people that think clearly and work very hard to not commit to anything that is wrong ought to be sort of rewarded instead of being attacked and endlessly, you know, being saying, you're such an idiot, you don't know thermodynamics, you know, what is that? Please. Leave me alone.
Let's get to this. I wanted to leave this for the end because ad hominem is not science, okay? And so I actually never wrote anything about Ned Nikolov's papers, but he said, first of all, I should point out here that Jonathan Cohler did not write this independently. Of course, that's just your basic lie. I wrote it independently. I wrote the paper. Now, he says he relied heavily on the paper by Essex et al. Yes, that's true. And he fully agrees with the conclusions made in this paper. Yes, that's true. I do fully agree because it's correct. And by the way, I also agree with Einstein and Richard Feynman because they were correct on their theories. But citing and extending previous work is literally how science is done. So the fact that I agreed with Essex is not a bad thing, as Ned tried to say. And I don't know where he got this idea that I did not write this independently. I wrote the whole thing. In fact, the paper actually comes from a talk I gave at DDP. And after I gave the talk, they asked me if I could turn it into a paper. So I extended it and made it into the paper. But, you know, the idea, you can go watch that video as well. All right, then he said about the subject of his formulas, his 7/2 KT stuff. He said, this is actually taught in undergraduate classes. So to say that nobody has mathematical proof when it's part of the standard textbooks to me is really weird. It seems that he doesn't really understand the subject matter at all. Now, just to note, I'm not interested in arguments of authority. But the fact is, I graduated from Harvard in physics, and I've taught physics for many years. So I do understand the subject matter quite well, actually. I would say probably not as well, definitely not as well as Christopher Essex.
Oh, yeah.
And Andresen and Bjarne Andresen.
Yeah, but
But I am much better than the average bear when it comes to understanding this physics, okay? My independent analysis relies entirely on undisputed first principles. It speaks for itself. Okay, so first of all, it's false that I wrote it with someone else, and it's also false that I don't understand. I understand it quite well. And now, as for Christopher Essex and Bjarne Andresen, two of the foremost authorities in the world, Ned says they don't understand the basics of thermodynamics or gas thermodynamics.
he invented the word gas thermodynamics. It's going to be really bad for Ned.
So that is actually a phenomenal ad hominem nonsense. Just to give you a very, 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 very brief précis of Christopher Essex. He's a pioneer on what? The thermodynamics of radiation, especially photons and neutrinos. He's also a pioneer on non-equilibrium processes, like what? The Earth. Entropy reduction in radiative and irreversible systems, anomalous diffusion, the behavior of thermodynamic quantities over extreme timescales. And he's collaborated with Andresen on a bunch of papers. I don't know how many, but 10 or 20, I'd say, maybe more. And he's coined a new term called slow time. He co-discovered the entropy production paradox in contexts like fractional diffusion, master equations, revealing deep subtleties in how entropy behaves in non-standard dynamical systems. So to say, that's like saying that Einstein doesn't understand the basics of quantum mechanics or general relativity. Yeah, I mean, he's one of the inventors of the subject, not inventor, but of this particular branch of the subject. As for Bjarne Andresen, he is the most active and influential person in the field of what's called finite time thermodynamics and related irreversible optimization thermodynamics. He's a highly respected pioneer. In fact, he helped coin and develop the term finite time thermodynamics.
FTT. Yeah.
And he was alongside, since the mid-70s, by the way, alongside collaborators like Peter Salomon and R. Stephen Berry. So
Stephen Berry is from University of Chicago. Yeah.
And these are two, Essex and Andresen are two of the most famous and well-known and experienced and published scientists in the field, but they don't understand the basics. That's ad hominem. Let's say for a moment they don't understand it. It still doesn't matter because the facts speak for themselves, right? So whether or not they understand it is irrelevant, but I can guarantee you both of them understand it to a depth that most people can't even imagine. Okay.
By the way, Jonathan, can we pause? I want to say one thing. Since I know Chris Essex personally for more than 20 to 30 years even, I would say that he will never respond to any of this so I want to thank Jonathan actually for doing so much work in defense of a good friend of mine too. And Jonathan, of course, quickly become my good friend too. It's all about, decency, you're doing the right thing. Understand the knowledge in the best way we know. We don't know everything. No one knows everything, including Chris Essex. But he is the best thinker we have on this topic. So please, have some respect and study more before you speak, because it's going to be very... We don't need lesson from Nikolov to say, how do we argue against IPCC, this and that. We don't need all of that argument. Even the stuff he worked on in terms of presenting all this radiation, I would urge him to even give a minimal study of the database of what NASA series, the cloud radiation budget thing, before you use the variable. Please understand the nature of how the measurement is done and how many problems they have in the database. It's a data product. Don't immediately turn into physical theory that you favor one way or another. Be more cautious. Right. I'm just a bit tired, right? You can make all the claim. Of course, we don't want to pick a fight. I mean, he's a good guy, but we're a good guy too. But you don't come around saying that we don't understand thermodynamics, this and that, or Christopher Essex don't know thermodynamics. That bothers me. This is why today I asked Jonathan to let me appear in this. Although I don't do much work on this. I'm trying to work with Jonathan on other topics to extend further this idea. So it is a very nice occasion. I really appreciate Tom Nelson for giving us this space to at least say what we need to say. Thank you. So Jonathan, continue. Sorry.
Yes. And, even if Christopher, Essex, Bjarne, and I don't understand thermodynamics at all, it doesn't change the result of this one bit, because the facts I quoted have nothing to do with me. They have nothing to do with Christopher Essex, and they have nothing to do with Bjarne Andresen. They're just first principles of fundamental math and fundamental physics. So that's why this ad hominem stuff has no place in science, because it's not relevant to the argument. Okay, so this altogether, as we've shown, every single point made by, every single point other than the blue where he agreed with us, we've shown is incorrect. So in other words, it should be all blue. This is why he's wrong. And thanks for listening. And do you have any questions for us, Tom?
I don't, except for, are you okay with sharing this PDF on my Substack? Would that be all right, or up to you?
Oh, absolutely. I can send you a PDF, or if you want, I can send you the whole PowerPoint if you want.
Yeah. If you can send me the PDF, I'll put that up on Substack, and then I'll put a link from the show description so people can look it all over. And
yeah, I can also give you the link to my live YouTube of my talk that was sort of the progenitor of this too.
Yeah, I'll put that.
One more point. Jonathan, remember we discussed it on the side, so we might as well talk in open. I mean, I hope that this is the end of it, and then let's not have any more ping pong, this and that. If Ned Nikolov is unhappy about this, then I guess, Jonathan, you have a solution. I would not participate further. It's good enough. This is the best we can. Let's not further do this. We don't want a ping pong. Like he's saying, oh, we misquote him, this and that. No, all this thing is just not waste of time, man.
Yeah, if the thing is, see, the way science is normally done is if someone has a qualm with a paper, they write a letter to the publisher saying, this is wrong, that's wrong. The publisher peer reviews it and then publishes it, and then the author has a chance to respond. Now, Ned didn't do that here. He came on your show, and all of a sudden I saw this thing claiming we're wrong about everything in our paper. So that's why I had to turn around and do this immediately. I would suggest, if he doesn't want to go through the standard scientific route of sending a peer-reviewed criticism, then if he wants to come on your show, and if you want to bring him on again, instead what we should do is a live debate, and then we won't waste so much time, because I could immediately answer and show what is wrong in his thinking. He's never written any of what he showed to you on here to me. He sent me some DMs in X here and there, each of which I responded to and showed why it was incorrect. But I was kind of surprised to see this thing where he had this big slide with all the red, So anyhow, we do it live in a debate. That's much easier than having to go through.
Yeah, but let's hope that, no, and indeed, that's the way to do this. I mean, Tom, we don't say anything, but you are good to let everybody speak their mind. That's the way to go, yeah.
Okay, very good. Anything else you guys want to say before we go ahead and finish her up here?
Nothing other than we've got a couple of new papers coming soon, hopefully.
Yeah, we hope we can come on your show to discuss why the Argo buoys are all crazy stuff, the measurement from ocean heat content and Earth energy imbalance concept is totally invented by a crazy guy like Jim Hansen, so on and so forth, and many more details. But yeah, and we got many things. I haven't even come back to talk about our solar flare, which we're very excited. By the way, we just got another paper published, so we'll discuss all of that when we have time. It's just too busy, and now we have to deal with Ned Nikolov stuff. But anyway, good enough.
Oh yeah, and we heard, by the way, the OHC paper, we're hoping will be out in a couple of weeks, if we're lucky. But we heard from one of the anonymous reviewers already, and the person said that they had never in their 40-year career approved a paper for publication with no changes before. So it came back with literally, and this is a long paper, by the way. The paper's like 34 pages, single-space stuff.
But you might as well review the method. The method is basically, Jonathan, now I would consider the maestro in terms of the proper and correct use of all this frontier AI system. They are extremely powerful beyond belief. I remember we talked about that a little bit, but within that 1 year space, it has gone all the way to the roof, in my humble opinion. And it can do far more capable. And it makes things so easy, and indeed that you really, really have to know how to prompt the system and to make sure that it don't spill out stuff that is wrong, all based on first principle, and that's the way. In fact, Jonathan himself created a filter that I think someday he hopefully will let everybody have it. We call it Jonathan filter. It's a filter to actually to avoid this system from telling you lies and always based on first principle. Don't go and cite consensus and IPC, all this real climate, all this stupid thing. It's a waste of time in some sense, because the only time we have is just to pursue truth. Then we are much closer to the truth, isn't it? That's part of my complaint all the time. But of course, I also enjoy part of this journey, but I don't enjoy talking bad about people, this and that. I want to find out what the hell is the truth.
Right.
Can we use this global temperature? No, we cannot really.
Right.
We cannot honestly use it to attribute this and that with the cause of this. So it's a huge confusion.
Yeah, the point about the AI is really important, because what happens is these AI systems are getting smarter and smarter and smarter. However, as you've noted many times, Tom, I've seen your posts, if you give it just sort of your generic, innocent, open-ended question, you get these very biased responses if the question is about a controversial subject, right? And that's still the case. However, at the same time, they've gotten much smarter. So if you force them, and by force, all I mean is you say to them, listen, I'm not interested in opinions. I'm not interested in consensus. All I want you to do is think through the first principles of math, physics, science, definitions, and carefully analyze this, and keep hammering on that, and say, all I want is the truth. I don't care what anyone's opinion is. I don't care what Willie's opinion is. Willie's opinion doesn't matter. His actual science, math, and papers that he writes matter, right? And so if you say that to the AI over and over again, they give you truthful answers. And what's happened is, especially Grok is by far the best, they go deep, deep, deep. And so they can analyze stuff. So we use the AIs not only to help in drafting, language, they also help in analyzing. And then after you write it and you've got a 34-page complicated paper.
Look at how much we make. We basically make the AI read all and synthesize all the documentation for Argo Float, my friend. We win.
Right. Right. It went and read. We have like 90 something citations on that paper, each of which is a long document. So it's read all of them. We've read all of them too, but it's read all of them, compared all of them. And we keep going back and saying, can you find any error? Can you find any error? So you use the AI iteratively, and you keep feeding it the paper, and you say, okay, here's this section. Is there anything wrong? Did we get any of the math wrong? Is there any logic wrong? Is there a paper we should have cited that we missed? And you keep doing it over and over. And we know a lot of the stuff right off the top of our head. Willie knows.
I realize that, Jonathan, we should stop now. Just a advertisement for the next session. We're going to have a lot of fun. But the bottom line is, you are condensing about 20 years of full-time research into about less than a month. I'm embarrassed to say that, but no human can have ability like that. It's just accumulated. This is really a very fascinating area for major growth and innovation and thinking to really push further the frontier of knowledge. Hopefully we'll get closer and closer to truth in whatever direction you're pursuing, right? In that particular aspect of problem,
It's a massive what do you call it? An amplifier.
Amplifier, yeah. No doubt.
It allows you to do way more. And if you already knew how to do it, you just didn't have the time to do it, right?
Yeah.
Now you can use it to compact in time by orders of magnitude. So if you know what questions to ask, you just keep asking questions. You keep saying revise. And by the way, very soon, the next few days, they're supposed to be coming out with Grok 4.2, which is supposed to be another quantum leap. And then Elon Musk was just interviewed, and he said Grok 5 is Q1. So that should be out within the next month or so, a month and a half, let's say. So, and 5 is supposed to be a massive leap. And you may even be getting to the point where you probably remember, Willie and I did this paper almost a year ago now, the Grok.
Yeah, exactly.
And that was like, compared to how it is to work with Grok now, that was like pulling teeth.
Yeah, I know.
You had to go over it many times, check things. It would get things wrong. It would give wrong citations, but you could keep asking it. You could keep searching, keep correcting, going back and forth and back and forth. Now the back and forth is massively reduced by probably 2 orders of magnitude.
Yeah.
So as you can get to
serious improvement. Yeah.
serious improvement.
That's enough advertisement. Good enough.
Oh, yeah.
All right.
30 more seconds here. I mean, I just asked
Sure.
Grok, are we currently experiencing a climate crisis? And it's pretty much, it's thinking it's going to say yes. Are we going to get to
Yes.
the point where it's going to say no? Or 10
No,
years
you
from now?
cannot. You got to ask it nicely. Think about how much of the information it learned from. It learned from all the junk.
Right.
It's very hard to unlearn something. Just like a human being, it's very difficult to unlearn anything, isn't it? I mean, you know what I'm saying. I thought I understand thermodynamics. I thought I know about Argo ocean heat content. I was slapping Jonathan off. Come on, this is uninteresting. And then he pointed out this thing for me. Oh shit. You have to quickly admit you don't know. That's one of the criticisms you're doing science. You say you don't know shit. You don't know anything. So stop. Take a pause. And then he starts showing me more and more what this machine is telling him, showing him. Obviously, he didn't go read himself. I had to say he kind of also cheated, right? He used the machine, but he's a smart guy. He checked the machine. And then that's why the whole thing becomes more and more and more beautiful. I really am very proud of
But
this
wait,
next paper coming up.
let's try this thing that Tom just gave it live right now.
Come on, watch this.
I'll share my screen.
Jonathan, it'll be too long. I think we'll do it next time. Yeah,
That's okay. Tom can cut it out and put it somewhere.
yeah, cut out this ending. Yeah.
So let's go to Grok
Yeah.
and we'll ask it.
Oh,
what was
if
the
he can
question?
show you, Tom, we should give you a law.
What was the question again about the climate crisis? What was it?
I just asked it, are we currently experiencing a climate crisis? And
Okay.
it thought for 22 seconds for me, and it said yes.
Okay. So please evaluate using first principles only whether we are currently experiencing
Climate crisis. Put a quote.
a quote climate crisis,
Yeah.
and and if so, please give me 5 specific
Reason.
current
Uh.
physical crises that you are referring to, and or if not, just say no. How's that? Is that a fair question?
All right. I mean, not much to it, but there's a slight twist already when you phrase it this way.
All right, so let's see what it says to that. And that's in fast mode. We could go into a deeper, longer mode. So the answer is no.
You see that? You see that, Tom? I will prove to you very clear. You have to know how to say things. You cannot just ask questions like that.
If you
That's
ask the
how we ask
question,
for creating an image from landscape, the guys from landscape format, it show all the landscape.
and look what it said, by the way. It said everything that's true, by the way. It even includes false stuff here, like GMST, by the way.
Right.
But even then, it still says no, right? So in other words, it says measurable physical changes are occurring, global average surface temperature, right? It immediately says, even that's a lie, but it knows it's not a crisis because measured physical changes is nothing. It says, however, labeling the current situation a crisis requires crossing into normative territory, deciding whether the rate, magnitude, and consequences qualify as an acute. Pure physical data show accelerating changes, but do not inherently prove a state of crisis. And there's no current physical crises. So there is no crisis. Okay. Now, but even here, for example, it got GMST wrong. You saw that, right? Which it will always do until you tell it.
Yeah, if you tell him to read
So what?
Essex and all, then you'll completely die. You understand? You just say it. No, test it.
But GMST
It's meaningless.
is not
Yeah.
a physical reality, is it?
Yeah, don't even say read Essex. If you put read Essex, they will immediately, oh, I'm sorry, this and that.
Okay.
Yeah, see that? It's local quantities like temperature you measure.
A constructed
point.
index. Now, the next level with a simple, by the way, in the old days, a year ago, if I said GMST is not a physical reality.
Oh, yeah, you'll
I
find
would
it.
immediately object and say, yes, it is, and it's verified everywhere, and blah, 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 blah. But now it admits immediately it's a constructed index. But what it will do is, again, the misconception that Ned was perpetuating. It'll say it reflects the average kinetic energy of molecules, which is not true. Okay, so now it's saying temperature itself is a physical property. That's true. And it reflects average kinetic energy in some systems. That's partially true. But here's where it says averaging temperatures over space introduces a statistical operation, right?
Experiences.
So there is no, and so it calls it a diagnostic summary statistic. And it claims that it correlates with energy imbalance, but it doesn't. Okay. So now you have to tell it to use first principles only and tell me what Essex, and this is the kind of thing that I think will go away at the next level, but even this is much easier than it used to be. Tell me what Essex et al. 2007 proves mathematically and from fundamental thermodynamics.
No.
Summarize for me, let's say. Summarize for me. What Essex et al. 2007 proves mathematically.
Once he invoked, it's gone. They completely wrong, this and that, all that shit.
So here you go. There is no, number one, there is no physically meaningful global temperature for their temperatures and
Same thing
intensity
you say,
variable.
right? You understand what I mean? There's not much.
Like pressure. Now, I didn't prompt it about any of this stuff. It just read the paper. It figured out it's not extensive. In thermodynamics, intensive variables do not add linearly when combining subsystems. There is no thermodynamic operation or physical process that defines or measures a total temperature. Okay? A single scalar temperature only has meaning for systems at or very near to thermodynamic equilibrium, where temperature is uniform and the zeroth law applies unambiguously. Earth fails this condition grossly, not a little bit, grossly.
Energy flux is the open.
So there is no unique. By the way, so I didn't mention temperature averages to it. It knows it now. Okay. So the concept of Earth warming, cooling as a whole in terms of single
is physically
ill-posed, meaning
using that phrase. Yeah.
Okay. In summary, from fundamental thermodynamics, there is no physically meaningful global temperature. So what you said before was wrong. And it usually just admits it at that point.
Yeah, it will admit, and then maybe explain that it's because of the literature I was reading. I was being fed shit, so that's why I talk shit. Excuse me. That was really bad.
Upon reflection, yes. The initial mention of GMST as a key measure was inconsistent with a strict first principles approach. From fundamental without relying on constructed observable local realities indicate ongoing changes, but do not aggregate into a single crisis threshold. Essex further proves that no such index can possibly represent energy or an index of anything in the physical world, does it? Doesn't it? I should. Yes. No global temperature, just index average mean can represent a physically meaning right. Key proofs from the paper, boom, boom, and he summarizes the proofs again. In the author's words, directly from the paper, the utility of any global spatial average of temperature field as an index has been presumed, not demonstrated. And in conclusion, there is no global temperature. Thus, strictly from first principles, any purported global temperature index cannot serve as a physically meaningful representation of energy content or any analogous extensive property of the climate system. It remains a statistical artifact without thermodynamic standing. Therefore, and the fact that people and organizations use it does not prove that it is useful, because useful in a scientific context as opposed to a propaganda context implies truthfulness, right? You can certainly use it for false propaganda. Yes. Paper's core arguments. It's, by the way, if you don't want it to keep repeating the same things, like it always repeats, you can tell it, just give me short answers. I could have done that here, and then it wouldn't keep repeating this stuff. But at the end, it'll say, right.
So you realize that, Tom, if you want to get the right answer, you really have to change your way of how you treat the system. It's not that this gentle little baby that is gonna just spit out anything that will be truthful, this and that. It doesn't do that. You have to be very strict with it. Ask the question.
But will it ever get to the point where it can ask it a simple question like, are we currently experiencing a climate crisis? And it'll say no.
don't
But
conceive
10
it's
years from now,
I think it will. I think my understanding of what Elon Musk is saying is that in version 5 it will, and maybe even in 4.2. But I can tell you it's way easier. In order to get to these kind of levels here in the earlier versions, I would have to upload the entire paper into the prompt because it had no knowledge of the paper at all, and they purposely did that in the past. And then you'd have to hammer on the points, and it would argue through many illogical lines. So you'd have to point out its illogic. Here, it gets to the logic quite quickly. And so, so for example, this proof, math proofs are absolute and eternal and not subject to empirical or opinion-based debate, right? And I should say, correct math proofs. You can always have an error in a math proof, right?
Yep.
But yes, okay. So it's a deductive change from axioms, right? So and wait.
A different way.
No, wait. So Essex is a pure math paper based on the most fundamental and undisputed axioms of thermodynamics, which is our most unchanged science of the past 150 years.
Yeah.
Right? Let's see what it says about that. Yes. Okay. Built directly on the most basic undisputed axioms. The core deductions rest on these right, it repeats itself again. And notice it points out local thermodynamic equilibrium. All these equations Ned was throwing around, PV equals nRT, of course, those are true for equilibriums. Okay. And non-uniqueness, no proxy, these points. So the criticisms, like from Real Climate, that's Gavin Schmidt's smear website, they shift to pragmatic utility, right?
Yeah.
But something that is false has no utility for truth-seeking. And it can only be pragmatic for propagation of falsehood. Let's see what it says to that. Yep. From the standpoint of rigorous truth-seeking, as opposed to instrumental or communicative pragmatism, something that is false in its fundamental physical claims has zero positive utility. The quantity of GMST is demonstrated via pure deductive reasoning. It has nothing to do with empiricism to lack any physical meaningful correspondence to the system's energy state, heat content, or any extensive thermodynamic property it is routinely claimed to represent, then it cannot truthfully inform us about whether the planet as a whole is accumulating heat, warming in an energetic sense, or undergoing a directional change in its global thermal condition. Any narrative built upon it that asserts such physical truths is propagating a falsehood at the level of thermodynamic description. And even there, you notice it says at the level, because that's more dissembling. So what I say
That's called dissembling. That when you add that, it's always they're very good at doing that because they still have all that filter.
doesn't, so I'll say to it, doesn't at the level of thermodynamic description simply mean in reality? Or is there some other, quote, description in the context of truth? They love to throw in phrases like that to confuse you. Yes.
So the language module
refers to fundamental physical reality. There is no other description, okay? When the goal is truth, see, but the IPCC, their goal is not truth. Their goal is to influence people. And so they chose GMST because it's simple to influence people with, because everyone thinks that they know what temperature is, and literally nobody does. So if I say
so hard, we already measure everything in the radiant fluxes, and then we convert to temperature so that
it's
we can
not that
talk about it.
complicated. Everyone thinks
That's
they know
crazy.
what
Yeah.
everyone thinks they know what temperature is,
That's
and
true.
literally nobody does. And therefore, if you say to someone the temperature went up, first of all, they immediately think that that meant it got warmer, which it
yeah.
doesn't. And second of all, you say the temperature went up, they immediately assume there is a temperature that went up, neither of which are true.
Because
It's all category. There is no global temperature.
so crazy, dude.
And whether the statistic goes up or down has no meaning whatsoever. And even if a temperature went up or down, has nothing to do with actual warming. So all of it is non-existent or mumbo jumbo used to confuse people who don't understand what's being said. And the IPCC purposely engineered that from the start. Okay. And so you can see thermodynamics provides the most basic ontological framework for understanding heat, energy, work, equilibrium, and non-equilibrium. What quantities like temperature, energy, and entropy actually are, and what operations on them are physically meaningful. Okay? So Grok gets it all immediately. And by the way, Gemini, which used to be horribly indoctrinated, now gets it all almost immediately too. It's not quite as smart as Grok. ChatGPT is the worst in that it will see the conclusion that it's arriving at through the truth, and it will begin to dissemble unbelievably, and it'll go on and on in circles. You know about, people who can argue forever about anything, right? That's what it does. It'll keep arguing and arguing and arguing and arguing, and after an hour of that, at the end, it'll say, I was wrong. And I'll say, okay, so why didn't you admit that at the start? Well, I was dissembling. I was doing this. And it admits to all that. I published a post on X.
It's a strategy. Yeah.
It's a strategy, yeah.
Okay.
All right, man.
Let's go ahead and wrap it up. But thank you very much. I hope to have you guys on again.